Hey everybody, welcome to week 9.2. We're going to talk about variation today. This section's mostly about three ideas: direct variation, joint variation, and inverse variation. So let's dive into those concepts, man. If x and y vary in such a way that their ratio remains constant, we say that y varies directly with x. There's a bunch of different ways that you can say this, and in order to get good in this section, you want to be able to rearrange the wording of these problems until you feel comfortable with it. So saying things like y varies directly with x, you'll sometimes see as y varies directly as x. There's not a whole lot of difference there. Y is directly proportional to x. That one is actually my favorite in this section. And then just y is proportional to x. And so this one tends to be my go-to personally in this section. Because of the way that I translate word problems directly into symbols, which we'll talk about in the upcoming examples. Now, as for y is directly proportional to x, or y varies directly with x, all of these represent the same equation. And when we parse this, I want you to learn how to break these up in terms of words. Y, that one's easy. That's just the symbol y. Varies directly as, or varies directly with, when rewritten. Sorry, I can't even speak. When rewritten as y is directly proportional to, means that it's almost equal to x. Y is directly proportional to x. It's not the same thing as y equals x. It means that it's off by some constant k. And the number k is called the constant of variation, or sometimes called the constant of proportionality. Or some variation of those terms. So the constant of variation or the constant of proportionality. Okay. So when we say direct variation, as we stated above, you'll see some statements like y is proportional to x, or y varies directly with x. And that equation is just y equals kx. You have joint variation, which is basically the same thing, but it involves more than one variable. In this case, just two variables, but you might see something like y is proportional to x and z, or y varies jointly with x and z. And then finally we have what's called inverse variation, which means that they don't vary directly with one another, they vary indirectly with one another. That's another way that we could state this. So this is y is inversely proportional to x. Y varies inversely oops, spelled that wrong. Inversely with x. And all that means is it's the same formula. Y is proportional to the inverse of x. So those are the key words that you want to watch out for. The terms being direct, joint, and inverse are going to key you in on what formulas to use in a word problem. So the book suggests that we translate varies as equal k. So what we have here is a basic setup. We're going to do some setup problems where we solve for certain variables, but typically, and we want to note this, students have a hard time with these problems because they try to solve it all in one go. Typically, this is a three-step problem. So let me show you what I mean. Any kind of variation problem should be done in 3 steps. Y varies inversely as x. So what we have is our step number 1. Y is proportional to the inverse of x, or y equals k over x is our setup. 2, we have our first round of information. First round of info to solve for usually k. And here we're told when y is 6, x is 3, or vice versa. So our first round of information plugged into our equation becomes 6 is equal to k over 3. We can solve for k, in which case 6 times 3 is equal to k, or k is 18. And then we're going to revise the equation and answer the problem. By the revised equation, I mean y is now inversely proportional to x by a factor of 18 for our constant of proportionality. And it says now find y when x is 9. Well, that's equal to 18 over 9 when we plug that value in, and what this reduces to is 2. So when x is 9, y equals 2. And there you have it in a little 3-step process. So let's try that 3-step again here. C varies jointly as A and T. So step 1 is our equation. C is proportional to, or jointly proportional to, A and T. C equals cat. That's weird. I wonder if someone planned that. Where this is our constant of proportionality. Step number 2 is going to be plug in the values that were given. 175 is equal to k times A, 2100, times t, which is 4, and that'll allow us to solve for k. Now, if you don't have a calculator, that's okay. You can just simply rewrite this as 175 over 2100 times 4, and just leave it like that. That's k. And then when we revise our equation, we get c is equal to 175 over 2100 times 4 times AT, and we'll plug in the next round of information. Find C when A is 2400 and T is 6. Now, before I didn't have too much luck, I don't think, trying to simplify this. However, now with these extra values in here, there's more to work with. So let's see. Let's kill some zeros first. That'll be good. This is equal to 175 times 24 times 6 divided by 21, which is 175 times 24 times 6 over 7 times 3. So let's see. 3 goes into 6 twice, and 7 goes into 175 25 times, and this is 25 times 24 times 2, which is 50 times 24, which is, let's see, 5 times 24 is 120 with another 0. 1200, I think, is our value. And there it is in our little 3-step process there. Okay. And then we arrive at the word problem. Oh, man. So this is exactly the same as what we just did. We just got to go through this and pull out our information. One's intelligence quotient, or IQ, varies directly as a person's mental age and inversely as that person's chronological age. So the first thing that we want to do is we want to turn this sentence into a working problem. So let's declare some variables. IQ, we'll let just be what? I for intelligence quotient. Their chronological age versus their mental age. Let's let M equal their mental age. Mine's about 5. I'm childish. And chronological age. Meaning their actual age in time and space, man. Okay, so what are we told here? Another way to write this is the IQ is direct or directly proportional to the mental age and inversely proportional to, I want to get this all on one line here. Chronological age. So, I've written it in such a way that I can easily parse this. Let's see, changing colors. We have IQ. I is directly proportional to M, which means that this is KM. And for our purposes here, the term and translates as multiplication. I'm trying to color code this so you can see how I'm breaking this down. And inversely proportional to the chronological age. Well, we already have a constant of proportionality. So 1 over C. Now, technically speaking, you could have done something like I is equal to my first constant of proportionality times M times a second constant of proportionality times 1 over C. And then you could have said I is equal to K1 times K2 M times 1 over C. And this could have simplified to I is equal to 1 big K3. Since those are both constants and a constant times a constant is another constant, we get just some constant. We still don't know what it is, M and 1 over C, which eventually will simplify to be I is equal to Km over C, if you want to write it that way. So this is our big form here. Okay, so that was step 1. Step number 2, let's go ahead and plug some information in. So let's see. A person with a mental age of 25 and a chronological age of 20 has an IQ of 125. So we have I is equal to 125, C is equal to 20, and M equal to 25. And so plugging that information into our equation, we get 125 is equal to k times 25 over 20. So we'll multiply both sides by 20. And then we'll divide both sides by 25. Note how I'm not breaking my neck trying to simplify this right out of the gate. If I can, I will. Okay, so 25 goes into 125 5 times. This is 20 times 5, which is 100. So the constant of proportionality is 100. Okay. Now, we'll revise our equation. The IQ is proportional by a factor of 100 to the mental age divided by the chronological age. And we'll use our second round of information here. Let's see. Now, they want to know what the chronological age is when the mental age is 40 with an IQ of 80. So IQ is 80, the chronological age is 40, and we should be able to figure out what their mental age is. So 80 is equal to 100 times the mental age divided by 40. We'll multiply both sides by 40 and divide by 100, and we'll get 80 times 40 over 100 is equal to their mental age. And what we have here is 32. And that's it, the mental age. Okay. So that is our practice, our guided practice for variation.